right, this is the beginning of the series of videos on the gas laws. We're going to start with Boyle's law in this video. And Boyle's law says that when the temperature and number of particles of gas are held constant, so there's no change in temperature and the number of particles stays the same, the volume, which is expressed with a V, is inversely related to the pressure P. Inversely related means as one increases, the other will decrease. So the equation that we can use to compare a system that has a specific pressure and volume, and then if we change one of those, we can look at how that impacts the pressure and volume on the other side. So the equation is P1V1 equals P2V2, P1 being the pressure of the initial system, volume, or V1 being the volume of the initial system, P2 being the pressure of the system after you've done something to it, after the change, and then V2 would be the volume after the change. So as volume increases, pressure is going to decrease and vice versa. So as volume decreases, pressure increases. That's what inversely proportional means. So if we just look at as the volume increases, the pressure decreases. If we increase the volume, so we have a gas that's trapped in this canister, and we pull this piston up, meaning we provide more space for these gas particles to move around in, they are going to hit the walls of the container less because they have more space to move. And we know that the pressure of a gas is measured by the amount of particles hitting the walls of the container. So as you increase the amount of volume, you will have less particles hitting the sides of the container, therefore the pressure will go down. On the other side of things, if you were to decrease the volume, you push the piston down, creating less space for those gas particles to move around in. Those gas particles are going to be more likely to hit the walls of the container, increasing the pressure. So that's what Boyle's law is saying. It's relating volume and pressure of a gas from an initial system to a final system once you've changed something. An application of Boyle's law that you're doing right now, I hope, is breathing. So in your chest, you have a diaphragm that sits underneath your lungs. And as your diaphragm moves downward, your lung volume increases, pulls your lungs open more, which decreases the pressure and causes air to move in through your mouth into your lungs. So that's what we do when we inhale. Likewise, as the diaphragm moves upward, it's going to decrease the volume inside of our lungs, which increases the pressure and causes air to move out, which is what happens when we exhale. So Boyle's law is literally happening right now. It is the reason why our lungs work the way that they do, which, yay for chemistry, you know? So when we look at a problem that we would use Boyle's law to help us with, it might look something like this. We have a balloon containing 30 liters of helium gas at 103 kilopascals. What is the volume of the helium when the balloon rises to an altitude where the pressure is only 25 kilopascals? And we're assuming that the temperature remains constant. And obviously the amount of gas remains constant because it's in a balloon. So I'm going to start by highlighting, you can underline it, circle it, whatever you want to do, the variables that are given to us and the variable that we're trying to find. So the known values we're given our initial pressure, which is 103 kilopascals. We're given the initial volume, which is 30 liters. And we're given the final pressure once the balloon has risen up in the atmosphere of 25 kilopascals. Our unknowns that we're trying to find would be the new volume in liters. Keeping in mind, when we use the equation for Boyle's law, our pressures, just like with the dilution equation, to make a connection for you, the pressures need to be in the same unit and the volumes need to be in the same unit. It does not matter what those units are, as long as they're the same on both sides of the equation. So that's how I know my volume will be in liters, or my V2 will be in liters, because my V1 is in liters. So I'm going to utilize Boyle's law, which is P1V1 equals P2V2. I can plug my known variables into the equation and leave V2 as my x. And I should hopefully be able to solve this. Do 103 times 30 divided by 25. And we will be using sig fig rules for this. So since we're multiplying and dividing, we can just look at total sig figs in all of our known values and round our answer to the same total number of sig figs as whichever one has the lesser amount. So this has 3 total sig figs, 3 total, 3 total. So when you calculate out your answer and round it, we should have 3 total sig figs for a new volume of 124 liters. To double check, right, we can look at this in terms of pressure and volume being inversely related. So it looks like our pressure is decreasing, right? It's going from 103 to 25. When our pressure decreases, that means that our volume is increasing. It's doing the opposite. So it makes sense that our answer should be higher than 30 liters, which it is. For our second example problem, we have a gas with a volume of 4 liters at a pressure of 205 kilopascals is allowed to expand to a volume of 12 liters. What is the pressure in the container if the temperature remains constant? And since we have a container, when we're working with a gas, it's usually a closed container, we can also assume that the moles of gas is also staying the same. So I'm going to start by highlighting the known variables and the unknown variable. So my known variables, I know P1, my initial pressure is 205 kilopascals. My initial volume is 4 liters. My new volume is 12 liters. And my unknown variable is my new pressure. And I know it's going to be in kilopascals because the units for pressure have to be the same on both sides of the equation. Same with volume. I'm going to use the Boyle's law equation, P1V1 equals P2V2. We can plug our known variables into the equation, solve for P2, and rounding to correct sig figs, right? We have 3 total here, 3 total here, 3 total here. We would be multiplying and dividing, so our answer should also be rounded to 3 sig figs to get an answer of 68.3 kilopascals for our new pressure. Let's double check that this makes sense. Our volumes, it looks like our volume is increasing, which means that our pressure would do the opposite. It should decrease, which if we're starting at 205 kilopascals, 68.3 is decreasing, so it does make sense. Okay, I want you to pause the video here, see if you can answer this question, and then hit play when you're done. All right, so we have a gas with a volume of 13.50 milliliters at a pressure of 23.7 atmosphere. It is allowed to expand to a volume of 16.75 milliliters. What is the pressure in the container if the temperature and moles of gas remain constant? So the known variables that were given to you is the initial pressure of 23.7 atmospheres. Initial volume is 13.50 milliliters. The final volume is 16.75 milliliters. and we're asked to solve for the final pressure, which will have the same unit as our initial pressure, so it should be in atmospheres. You'll want to utilize the Boyle's law equation, which is P1V1 equals P2V2. Plug in your known variables and solve for P2. And you should have had P2 come out to 19.1 atmospheres, and it should have been 3 sig figs because we have 3 sig figs here, 4 here, and 4 here, which is why we want 3. 3 is less than 4. So let's just check and make sure that this answer makes sense. We are increasing our volume, which means that our pressure should do the opposite. It should decrease with an increase in pressure. So going from 23.7 atmospheres to 19.1 makes sense logically. It should go down. Pause the video here, see if you can get the second question, and then hit play when you're done. What pressure is required to compress 196 liters of air at 1 atmosphere into a cylinder whose volume is 26 liters? Your known values were the initial pressure of 1 atmosphere. The initial volume is 196 liters. And your final volume is 26 liters. And you are asked to find the final pressure, which will have a unit of atmospheres because the pressure units will stay the same on both sides of the equation, just like the volume unit is. We're utilizing Boyle's law for this. We know that P1V1 equals P2V2. We can plug our known variables into the equation. Looking at sig figs, there's 3 sig figs here, 4 here, and 3 here. So we would want our answer to have 3 total sig figs. So you should have rounded your final pressure to 7.55 atmospheres. So that is it for Boyle's law. You have some practice specifically for Boyle's law in your gas laws practice packet. And then there's some more in the mixed practice, which you might want to wait on until you learn the other laws. But that's it for this video.